Welcome to our exploration of how heating, ventilation, and air conditioning systems maintain clean rooms. We'll delve into the engineering, airflow science, and filtration technology that ensure minimal contamination. A clean room is a controlled environment where airborne particulate contamination is meticulously managed. International Organization for Standardization 14644-1 defines cleanliness classes from International Organization for Standardization 1 to International Organization for Standardization 9. For instance, International Organization for Standardization 5 allows up to 3,520 particles per cubic meter, while International Organization for Standardization 7 permits up to 352,000, and International Organization for Standardization 8 allows up to 3,520,000 particles, all greater than equal to 0.5 micrometers. The heating, ventilation, and air conditioning system is crucial for cleanroom functionality. It manages airflow rate, filtration efficiency, pressurization, temperature, and humidity. Without precise engineering, a cleanroom cannot achieve its classification standards. Air changes per hour, ACH, is crucial in cleanrooms, indicating how often the room's air is replaced hourly. An International Organization for Standardization 5 cleanroom achieves up to 240 air changes per hour, significantly higher than a typical office. This high ACH rate effectively dilutes and removes particles, preventing them from settling on surfaces. High-efficiency particulate air filters capture 99.97% of particles 0.3 micrometers. Standard in International Organization for Standardization 7 to 8 cleanrooms. Ultra-low penetration air filters with 99.9995% efficiency for particles 0.12 micrometers are essential in International Organization for Standardization 3 to 5 semiconductor fabs. Pre-filters extend high-efficiency particulate air life by 3 to 5 times. International Organization for Standardization 5 rooms need 35 to 70% ceiling coverage with high-efficiency particulate air, ultra-low penetration air units for uniform airflow. Laminar airflow is essential for ultra-clean environments, moving air in parallel sheets at 0.3 to 0.5 meters per second to sweep particles away. In contrast, turbulent airflow is used in less critical spaces, focusing on high air changes per hour and dilution rather than directional force. Cleanrooms maintain pressure differentials to prevent contamination. The cleanroom core is pressurized at plus 15 pascals above the corridor, the gowning room at plus 10 pascals above the hallway, and the corridor at plus 5 pascals above ambient. This pressure cascade ensures air flows outward, safeguarding the environment. Temperature and humidity control is crucial in cleanrooms. Even slight deviations can lead to thermal expansion, static buildup, or microbial growth. Heating, ventilation, and air conditioning systems maintain precise conditions: 21 degrees Celsius plus or minus 0.5 degrees Celsius in semiconductor fabs, 45% plus or minus 5% relative humidity in pharmaceutical cleanrooms, and dew point control below 1% relative humidity in lithography areas. Modern systems adjust within 30 seconds. Each industry establishes specific particle count benchmarks to protect product integrity. For instance, International Organization for Standardization Class 3 allows a maximum of 0.5 particles per cubic meter, while Class 8 permits up to 3,520 particles. These limits are crucial, as even one stray particle can ruin a photolithographic circuit or contaminate a sterile drug batch. The HVAC loop operates with a closed-loop recirculation system, reusing 80 to 90% of room air. This approach significantly cuts energy costs while ensuring high cleanliness standards. Key components include laminar flow, HEPA/OPA filters, pre-filtration, and return air mechanisms. Clean rooms are energy intensive, using 10 to 100 times more energy per square foot than standard buildings. A 1,000 square meter International Organization for Standardization 6 fabrication facility can consume 3 to 5 megawatts continuously. Air handling units are the largest energy consumers, accounting for approximately 42% of total usage, highlighting a significant opportunity for efficiency improvements. Continuous environmental monitoring systems ensure real-time tracking of particle counts, pressure, temperature, and humidity, triggering alarms instantly upon deviations. Laser-based particle counters sample at 1 cubic foot per minute, logging every 60 seconds. Pressure sensors alert at plus or minus 2 Pascal deviations. International Organization for Standardization 14644-2 requalification is mandatory every 6 to 12 months based on risk classification. Heating, ventilation, and air conditioning systems can fail due to high-efficiency particulate air filter breaches, pressure loss, air changes per hour drop, humidity spikes, and temperature drift. These failures, caused by factors like age, damage, or control valve issues, lead to significant contamination risks, including increased particle counts and microbial growth. Immediate attention is crucial to maintain cleanroom standards. When a cleanroom door opens, particle counts spike immediately. An International Organization for Standardization 5 room with 240 air changes per hour recovers to class-compliant levels in under 150 seconds. An International Organization for Standardization 7 room takes a similar time but starts from a higher spike. High air changes per hour means faster recovery and less risk exposure. Variable speed drives cut fan energy by up to 50% during low occupancy by adjusting air changes per hour while keeping International Organization for Standardization standards. Heat recovery wheels reclaim 60 to 80% of thermal energy from exhaust air, reducing heating and cooling demands. Artificial intelligence-based controls use machine learning to predict contamination events, adjusting systems 15 to 30 seconds in advance. ISO 5 cleanrooms require up to 240 air changes per hour. HEPA filters capture 99.9995% of particles at 0.12 micrometers. Cleanrooms consume 100 times more energy per square foot than standard buildings. Semiconductor fabs maintain a precise temperature tolerance of plus or minus 0.5 degrees Celsius. Heating, ventilation, and air conditioning systems are the backbone of cleanrooms, ensuring International Organization for Standardization compliance through precise air changes, filtration, and environmental control. Continuous monitoring and aggressive optimization with variable frequency drives and artificial intelligence can significantly reduce energy use while maintaining standards. Every specification directly impacts contamination outcomes, highlighting the critical role of heating, ventilation, and air conditioning in cleanroom operations.